Okay, question 4. We've got a lovely network there, and look, they have to be inspected. So I think this might be route inspection. Okay, read it through carefully. Uh, each tunnel at least once. Okay, minimize the length. Yes, it's route inspection, and we are starting and finishing at the same point. So we need to make all the odd vertices even. So route inspection algorithm, so there's no doubt about what the method is. So how does route inspection work? Well, you have to start by telling me the odd valencies. Okay, so list them, pair them up all the different ways you can. For each pairing, you're going to tell me the total of the two routes you have to consider. I think there are just two. I think there are 4 odd vertices, so you're going to have 3 pairings with 2 in each pair. So you're going to be adding 2 route lengths together, getting 3 numbers which I want to see, and one of those 3 numbers will be the best and will show the paths that need repeating. But what does it ask for? We need to find the tunnels that will need to be transversed twice. Okay, so suppose you decide that there's a section from D to F. One of your brackets is D to F, and that needs repeating. It won't be because they're even, but never mind. If it was D to F, okay, there is no tunnel from D to F. So it doesn't want you just to write out this pair and this pair, because they may not be tunnels. You have to go back to the diagram, and if it's a route from D to F, what were the tunnels on that route? And it looks like if it was that one, it would be D to C and C to F that would be repeated. So you're telling me the individual tunnels. You're not telling me just D to F. It won't get you any marks. Okay? So in part A, make sure you've told me the tunnels. And in part B, well, we've got to get a route of minimum length starting and finishing at A and state the length of your route. Well, the length of the route, you can take your repeated bits and add it on to the total length of the tunnels, which they are normally kind enough to tell you. But for the route, what you have to do is actually, on your diagram, draw on a doubled edge, an extra edge between anything you're going to repeat. So if you're repeating D to G, you'd be drawing an extra one on there, and then on your diagram, you use the extra edges you've added, as well as the ones that are originally there, and you write down a sequence of letters that works. So you have to do those 2 things in B, the minimum length route, state the route, and state the length of the route. Okay, now in part C, we've got a new tunnel, 10 kilometers long, and he's going to have to include it. So we're just adding a new 10-kilometer route from C to G on the diagram. So you can put it in. So we're putting in an extra 10 here. And what you need to do is think, how does that change the problem? If you're starting again from scratch, you'd start again by thinking about odd vertices. Okay, now C and G happen to be interesting in that they were odd, but with this extra tunnel, they are now even. So do I have to make them odd anymore? No, I don't. Okay, I do have to use this 10 from C to G. Okay, however, I don't have to make all the 4 original odd vertices even anymore. So I'm going to save on some of the work I had to do before. Okay, so you have to tell me whether the overall effect of that, okay, is going to be an increase or a decrease. Okay, but it's not just, we're only going to now have 2 odd vertices, so whichever pairing represents the 2 remaining odd vertices, we will save, we'll still have to repeat that edge, but we'll save the rest of this best total you added on. But on the other side, we will have to use this 10 here. Okay, so you have to work out what goes on and give me a clear answer. Okay, lots of you just told me they'll have to do 10 more, which is just not true, because he'll have to do less somewhere else as well. So get your head around it. I hope that makes sense.